In the last section, we went over the majority of our client pod.yaml file. We spoke about what a pod is and what its purpose is. We also spoke about the spec section down here a little bit, but we have not yet spoken very much about this metadata section. Now, very quickly on metadata, the name is pretty much what you would expect. It's going to name the pod that gets created, and this is mostly used for a lot of logging purposes. We're going to see the name of client pod used when we start using kubectl to print out information about our running cluster at the terminal. Now, the other piece of information inside of metadata is labels right here with component web, and that's very tightly coupled to the other config file that we're going to start to discuss right now. So in this section, we're going to focus on the second config file we put together, the one with a kind of service. So let's talk about what's going on inside here. All right, so at this point, we've spoken about the object with type pod. A pod is used anytime we want to run one or more very closely related containers. So we're now going to start talking about a second kind of very commonly used object. The second object type that we're going to discuss, and again, this is a type that we're going to be discussing just so much throughout this course because all this networking stuff is so important to understand. Anyways, second object type, services. We use this object type anytime we want to set up some amount of networking inside of a Kubernetes cluster. So let's take a look at a couple of diagrams that are going to give you a better idea of exactly what a service is and how it behaves. Now, the first thing I want you to understand is that in the world of pods, we have basically just pods. That's it. Like, that is the object type. But in the world of services, there are 4 very commonly used subtypes. In fact, there's only 4 subtypes. And so I've listed all the subtypes of the service object type right here. So as a service, we can create a service of type cluster IP, node port, load balancer, and ingress. Inside of our particular file, we specified a object type or a primary object type of service with the kind property up here. And then inside of the spec section, we specified a subtype or a type of service known as a node port. So we are making a node port service. The purpose of a node port service is to expose a container to the outside world, or in other words, to be able to allow you, like you as a developer on your computer, to open up your web browser and access that running container. A node port service is only good for development purposes, and we do not use node port as a service type inside of production environments outside of 1 or 2 very specific exceptions. And actually, one of those exceptions is something we're going to cover later on inside this course. Now, you'll notice that on the other service types on here, I'm not putting any notes or anything on here. We are going to talk about the other service types in tremendous detail throughout this course. Again, services and networking is a very important topic to understand. But if I added in those other descriptions right now, it would just be a little bit confusing. So I'm going to leave the other descriptions off. And for right now, we're just going to focus on the node port service type. Okay, so again, node port is something that we use to expose a container to the outside world and essentially allow you and I to access that container inside of our browser. Now, I want to show you a series of diagrams to give you a better idea of what this service is doing for us. So inside this diagram, the overall blue box is our computer. And so at some point in time, you and I are going to want to open up our browser and connect to that multi-client container that is running inside of our pod. That pod and the container inside of it are running on the local Kubernetes node. Remember, this is the VM created by Minikube that is running on your local machine. Now, when we create that service of type node port, it's going to set up a communication layer between the outside world and the container running inside of that pod. You'll notice that there's another box on here called the kube proxy. Every single node or every single member of a Kubernetes cluster that we create has a program on it called the kube proxy. The kube proxy is essentially the one single window to the outside world. So anytime that a request comes into a node, it's going to flow through this thing called the kube proxy. This proxy is going to inspect the request and decide how to route it to different services or different pods that we may have created inside of this node. So right now, I'm only reflecting one service right here, but over time, we might end up with multiple different services. Something like that right there, as messy as that may be. And so when we end up with multiple services inside of a single node, it would be up to kube proxy to make sure that incoming requests are sent off to the appropriate service. Now, when a request comes into the node port service that you and I are going to create, it's going to attempt to take that request and forward it onto port 3000 on our multi-client container that we defined to run inside of our pod. Now, that gives you an idea of the placement of the service here, but that doesn't really kind of describe everything else that's going on inside of here. So what's going on with the 3 different ports? And what's going on with the selector down here? Let's take a look at another diagram that's going to be slightly more detailed than this one right here, that's going to give you a better idea of those different pieces of configuration and their purpose. Okay, so very similar diagram, just with more detail added in. I just got to fix that thing or I'm going to go crazy. Okay, so on the service, you'll notice I added in kind of a long statement right here. If you look at the client configuration file, you'll notice that at the very bottom is a selector that says component:web. You'll also notice that there's nothing else inside this file that seems to indicate that it should be that this service should be handling network traffic for our pod with a name of client pod. So here's the pod file. It's got a name of client pod. Here's the service file. Nowhere in here do we say client pod. So in other words, there's nothing inside of here that says, I need to send traffic to client pod. There's no declaration like that inside of here. Instead, rather than referring to the service, or the pod that we want to have this service direct traffic to, rather than using any naming system, we instead use a system in Kubernetes called the label selector system. So inside of this service file, you'll notice that down at the bottom, we have a selector of component:web. And then over here, back inside of the pod file, we have a metadata labels property of component:web. That's how these 2 different objects get linked together. When the service first boots up, it's going to say, okay, I need to do some port forwarding. I don't know who I'm supposed to forward this traffic to. It's then going to see its selector property down here, and it's going to say, oh, okay, I'm going to look for any other pod or any other object that is running that has a key value pair of component:web. And if I see any other object running inside this Kubernetes cluster with the label of component:web, I'm going to direct all traffic to these ports on that thing. So the service that we've created and the pod that we created are linked together by the label inside the client pod and the selector inside the service. Now, the one thing that I want to make sure is really clear is that the selector that we've used here of component:web is 100% arbitrary. So we could have just as easily called this thing like tier front end. If we had made that change, we would just need to make sure that the client pod has the same label as well. And so back inside the client pod, we would need to have tier front end as well to make sure that the 2 are 100% identical and match up perfectly. Now, I am going to undo those changes, and I'm going to go back over to component:web on both configuration files. Okay, so again, when the service boots up, it says I'm going to look at my selector property, and it's going to see that it has a key value pair of component:web. It's then going to reach out in the Kubernetes cluster, and it's going to find every other object that has a label of component:web. And it's going to attempt to expose port 3000 to the outside world, more or less. And so, of course, our pod needs to have the appropriate label of component:web. Okay, so that brings us up to speed on the selector inside the client node port file and the label in the client pod file. Now, the last thing I want to tell you about is the collection of ports right here. We have ports, target port, node port, all these different things. Now, one quick thing I just realized, I put ports right here. That is a little typo. It should be port singular, like so, my mistake. I'll mention that again at the end of this video, just to make sure that if you're speeding through this section, you don't miss out on that little fact. Okay, so in the service, we have a port section. This is describing all the different collections of ports that need to be opened up or mapped on the target object. One thing I want to point out here is that the service ports property is an array, and so we could very easily have additional ports that we're trying to be mapped on here as well. So we could do like, I don't know, 9,000 or whatever it might be. Now, something that might seem a little bit weird is the fact that we have 3 different ports inside of here. First thing I want you to notice is that the target port of 3000 is identical to the container port over inside of the pod definition. Now, that's not really a lot of help. Let's just look at a diagram. It's going to explain these different things. All right, I'm wasting time. Here we go. Okay, so inside the node port service, we're exposing those three different properties, or we have defined those three different properties. Now, the first thing that we're defining inside there is port. Port for you and me is more or less 100% worthless for the application that we are putting together right now. The port property is going to be the port that another pod or another container inside of our application could access in order to get access to the multi-client pod. So this multi-client pod right here, that represents the actual pod that the service is trying to map traffic over to. So we can imagine if there is some other pod inside of our application, like let's say other pod right here, if there's some other pod that needs access to multi-client, it could connect to it through this port designation right here. And so again, for you and I, for the application we're doing right now, this port property is not useful because we do not have any other objects or anything else inside of our Kubernetes cluster that's going to attempt to reach into that multi-client pod. Now, the next property inside there is the target port. So as you might imagine, the target port is the port inside of that pod that we want to open up traffic to. We used a target port of 3000 right here, which indicates that we want to send any incoming traffic into port 3000 inside of this pod. And port 3000 has been mapped up to the multi-client container. Now, the last thing on here is the node port. You'll notice that for the node port, we used a rather large port number. I used 31515. Now, the node port is the one that you and I probably care about the most whenever we make use of a node port type. The node port is the port that you and I inside of our browser are going to access whenever you and I want to actually test out the container running inside that pod. So the node port right here is going to be essentially what you and I type into our browser. So as the URL, we'll do whatever the IP address is, :31515. So we're going to type in that port into our browser in order to access the multi-client pod. So again, we can kind of ignore the port property for this application we're doing right now. The node port is what gets exposed to the outside world, and the target port is what gets opened up inside of the targeted pod. Now, the last thing I want to mention is that the node port is going to always be a number between 30,000 and 32,767. If you do not specify the node port, so we are not required to specify it, we could actually delete it if we wanted to. If we do not specify that port, one will be randomly assigned to us, and it will be between 30,000 and 32,767 as well. Now, the reason, or I should say one of the reasons that you and I do not make use of the node port service in a production environment is because of these funky port mappings. Obviously, when a user goes to something like google.com, they want to go to google.com. They don't want to go to google.com:351515 or whatever, right? Now, again, that's just one reason of many that we do not use a node port in a production environment outside of some very specific exceptions. Okay, so I think that explains just about everything inside of our client pod file and the client node port file as well. So now the last thing we have to do is take these two configuration files, and we're going to load them into our Kubernetes cluster through the kubectl command line tool. So quick pause, and we'll come back in the next section.